So today we have to see the next concept, that is partition and covering of a set. Okay. So first of all we have to understand what is meaning of partition and what is meaning of covering. So let us see the definition for partition. Let S be a set and A is equals to set which is consist of elements A1, A2, Am, where each I from 1 to M is a subset of S. So I from 1 to M, this is equals to set S. So here we can say that set S is consist of elements A1, A2, Am. Okay. So all these elements are included in set S. Then set A is called as covering of S. So here we can say that A is a covering of S because A is containing all the elements of S, and those elements are A1, A2 up to Am, and sets A1, A2, Am are said to be cover of S if the elements of A, which are subsets of S, are mutually disjoint, then A is called as partition of S. Okay. So here it is the concept of partition. So first we will see what is meaning of covering. Suppose set S is given and which is consist of elements A1, A2 up to Am. Then if you take union of these all these elements, it will constitute set S. So here this set A, which is containing all the elements, is called as covering of set S because it is covered, or we can say set A has covered all the elements of set S. That's why A is called as cover of set S. Okay. So this is the concept of covering. Now suppose A1, A2, Am, all these are separate sets, and if nothing is common between all these sets, if those are mutually disjoint, then we can say that these are partitions of set S. Okay, so this is the concept of partition and covering. So let us see one example, then you will understood what is the meaning of partition and covering. So let S is equals to set which is consist of three elements A, B, C, and consider the following collections of subsets of S. So these are the some collections like A, B, C, D, E, F. Okay. So out of all these sets we have to decide which one is covering and which one is partition. Okay. So let us consider first set, that is set A. Now we have to decide whether this one is partition or covering. Covering means what? It should cover all the elements of given set. Now here given set is set S and this is containing three elements A, B, C. Now we have to check whether set A is containing three elements A, B, C, S. So set A is containing A, B and C. All three elements are included here. So we can say that set A is a covering of set S. Okay. Now let us check whether this one is a partition of set S. So what we have seen for partition, the elements of given set should be mutually disjoint. Means what? Nothing should be common between them. But if you observe this set, it is consist of two subsets. First set is containing AB, second one is containing BC. So here element B is common between these two sets. So we cannot say that this one is mutually disjoint. So this is only covering of given set and not a partition. So this is the concept of partition and covering. Have we understood what is meaning of partition and covering? Hello?
Yes, sir.
Ma'am, repeat again.
ओके. सो कवरिंग म्हणजे काय असतं, दिलेल्या सेटमधले जर सगळे एलिमेंट त्या सेटमध्ये असतील आता हे जर एक्झाम्पल कन्सिडर केलं तर सेट एस मध्ये किती एलिमेंट आहेत? 3 एलिमेंट आहेत, ए बी सी. आता आपल्याला चेक करायचं आहे वेदर ए इज पार्टिशन और कवरिंग ऑफ गिवन सेट. नाउ ए इज ऑल्सो कंटेनिंग ऑल थ्री एलिमेंट्स ॲज ए बी सी, म्हणजे एस मधले सगळे एलिमेंट ए मध्ये आहेत. सो ए इज कॉल्ड एज कवरिंग ऑफ सेट एस. सगळे एलिमेंट आहेत म्हणून आपण काय म्हटलं, ए इज ए कवरिंग. नाउ वी हॅव टू चेक वेदर ए इज ए पार्टिशन. आता पार्टिशन कधी म्हणणार आहे? जर दिलेल्या सेटमध्ये एकही एलिमेंट कॉमन नसेल तर त्याला आपण पार्टिशन म्हणणार आहे. आता चेक करा, ए मध्ये जर बघितलं तर पहिला सबसेट कोण आहे? ए बी, अँड सेकंड सबसेट इज बी सी. बट हियर एलिमेंट बी इज कॉमन बिटवीन these two sets. That's why this is not a mutually disjoint set. So this A is not a partition. This is only covering. जर एलिमेंट कॉमन असतील त्या सबसेटमध्ये तर ते पार्टिशन नसतं, आणि सगळे एलिमेंट असतील तर ते कवरिंग आहे. तर बघा, इफ यू कन्सिडर सेकंड सेट, that is set B. Again this set is consisted of two subsets. First one is set A, second one is set C. Now first of all we have to check whether this one is a covering. आता covering आपण कधी म्हणणार आहे? If this set is containing all the elements of original set, then only this is called as covering. Now here B is containing just two elements as A and C, but B is missing here, element B is not here. That's why we cannot say that this is covering. So this is not a covering. Now check for partition, whether this one is a partition. No, because again element A is common between these two subsets. That's why we can say that B is neither partition nor covering. Have you understood now?
Yes, ma'am.
Okay. Now you have to tell me what about C, whether this one is partition covering or both partition covering or neither partition nor covering.
Both covering and partition.
Yes, it is both partition as well as covering. What about D?
Both partition and covering.
Yes, both partition and covering. E?
Both.
Both. F?
Only covering.
Only covering, not a partition, because element A is common between all these three subsets. Okay. So there is one note, every partition is a covering. Now if you observe here, whenever we have said it is a partition, like set C, set D, set E, all the time it is a covering. Okay, so this is very important note, every partition is a covering. Okay. So here next example also based on partition and covering. Here set A is given and which is consist of three elements 1, 2, 3. Then again we have to recognize whether these given sets are partition or covering. So consider first set. So this is a partition because nothing is common between all these sets, and it is requires that to be a partition it must be a covering. जर ते partition असेल तर त्यामध्ये first important thing आहे, it should cover all the elements of original set, and that set is containing 1, 2, 3. So your partition must contain 1, 2, 3. And there should not be any element common between subsets. Okay. Now second one, again it is a partition because it is containing three elements and nothing is common between subsets. Now third one, it is covering. Why it is covering? Yes, can you explain why this one is a covering and not a partition?
It covers all the element of set
2 is
A.
common in this.
A. Yes, it is containing all the elements of original set, and one element 1 as well as 2 is common between some subsets. That's why this is not a partition but it is a covering. Fourth one, yes, it is a partition. Then fifth, it is also partition. Then sixth one, okay. So here this is not a partition as well as not a covering, because this is only containing two elements, as 1 2 3 is not there, that's why this is not a covering. And this is not a partition. Why? Because to be a partition it should be a covering. जर कवरिंग नसेल तर ते पार्टिशन पण नसतं. जर कवरिंग असेल देन ओनली वी कॅन चेक फॉर पार्टिशन. कंडिशन समजली का? आपण काय म्हटलं, एव्हरी पार्टिशन इज ए कवरिंग. जर ते पार्टिशन असेल तर ते कवरिंग असणारच आहे. फक्त कवरिंग असेल तर आपल्याला चेक करायचं आहे वेदर इट इज पार्टिशन ऑर नॉट. आता इथे हे कवरिंग पण नाही आहे, सो इट इज नॉट रिक्वेस्ट टू चेक फॉर पार्टिशन. it never be a partition. And for last one, it is a covering but it is not a partition because element 2 is common between these two sets. So this is the concept of partition and covering. Got it?
Yes.
Hello?
Yes, ma'am.
Okay. Okay. Now we have to see the next most important part of this chapter, that is partial ordering. Okay. So what is the definition for partial ordering? A binary relation R in set P is called as partial ordered relation or partial ordering in P if and only if R is reflexive, antisymmetric and transitive. So as we have seen the definition for equivalence relation, the equivalence relation must satisfy three properties. What are those properties?
Symmetric, reflexive and transitive.
Yes, RST, that is reflexive, symmetric and transitive. Likewise, if that relation is satisfying three properties, reflexive, antisymmetric and transitive, that is RAT, then that relation is called as partial ordering relation. Okay, so this is the definition. So if this is the symbol for partial ordering, if this is a partial ordering on P, then order pair P comma partial ordering is called as partial ordered set or poset. म्हणजे काय, if you apply any partial ordering on any set, then that set is called as partially ordered set or poset. PO is for partially ordered and that relation is applied on set, that's why partial ordered set or poset. So this is the definition for poset. Now next concept is toset, that is totally ordered set. So TO, this is for totally ordered. Again this is applied on set, that's why this is called as toset or chain. Okay. So now we will see what is meaning of poset and toset. So let P partially ordered set be a partially ordered set if for every xy belongs to P we have either x is less than equals to y or y is less than equals to x, then this is called as simple ordering or linear ordering. Okay, and this is called as totally ordered or toset or chain. Now we will see one simple example. Suppose there are two different elements x and y and x is less than y. So we can take two circles to represent these two elements. Now suppose I think diagram is given here. So from this diagram, I can take this example. Suppose there are two elements, 1 and 2, and 1 is less than 2. Okay. So first of all, I have to draw two circles to represent these two elements as 1 and 2. Now I have to decide what is the position for element 1. As element 1 is less than element 2, I should draw the one below 2. So this is the diagram for these two elements, and this is called as Hasse diagram. Okay, that part we will see later, but here just consider that these two elements are connected by one line. So we can say that this is a chain. Okay, so this is a totally ordered set or toe set. टो सेट आपण का म्हटलं याला किंवा चेन का म्हटलं बिकॉज दीज टू एलिमेंट्स आर रिलेटेड टू ईच अदर अँड दीज आर फॉर्मिंग ए चेन दॅट्स वाय दिस इज ए कॉल्ड एज टो सेट. नाउ so here some examples are given for partially ordered relation. So this partially ordered relation can be less than or equals to or greater than or equals to, or it can be relation of inclusion. So we have seen what is the definition for power set, and that power set is given by formula 2 raised to a. So if your set A is consist of 3 elements, then power set of A will contain total 8 elements, because this formula is 2 raised to a, and here value for A is 3. So it will give you 8 elements. So likewise you can apply any relation as a partially ordered relation. Again we can consider the relation of divides and integral multiple of. So if A and B are the positive integers, then we can say that A divides B, and this can be written as A divides B if and only if there is an integer C such that A into C is equals to B, or B is an integral multiple of A. So now how we can apply this divides relation on any set? So now consider set X is given, which is consist of 4 elements 2, 3, 6, 8, and this partially ordered relation is a divides relation. So now we have to apply this divides relation on this set X. Okay, so we have to find such order pairs those are satisfying this divides relation. So consider first order pair 2, 2. So here 2 divides 2. So we can consider this order pair for this partially ordered relation. Now 3, 3. So again 3 divides 3. 6, 6, 8, 8, 2, 8, 2, 6 and 3, 6. So here each and every order pair of this relation is satisfying this divides relation. That's why this is called as, or this partially ordered relation is called as divides relation. Okay. So likewise we can check for integral multiple of. So now we have to apply the relation integral multiple of on this set X. So we can say that 2 is integral multiple of 2, 3 is multiple of 3, 6 is multiple of 6, 8 is multiple of 8, again 8 is multiple of 2, 6 is multiple of 2 and 6 is multiple of 3. So all these order pairs are satisfying this integral relation. That's why all these are the partially ordered relations. So just keep in mind that partially ordered relation can be less than or equals to, greater than or equals to, it can be a inclusion, or it can be a divides or integral multiple of. Any kind of relation is a is a partially ordered relation. So last time they have asked one question based on it. give the list of partially ordered relations. In this case, you have to give all these relations because these are the some examples of partially ordered relations. Okay. Now, how we can represent this partially ordered relation? So, for that purpose, there is one diagram given, and that diagram is called as Hasse diagram. Okay. Now, we will see how to draw a Hasse diagram. So, suppose in a partially ordered set, P partially ordered relation on element y belongs to P is said to be cover an element x belongs to P if x is less than y and if there does not exist any element z such that z belong to P and z is less than equals x is less than equals to z and z is less than equals to y. Okay. Now what is meaning of this statement? So suppose there is any partially ordered set P and that is containing one element y. Okay. And there is any another element x such that x is less than y. So how we can represent that x is less than y? Suppose this element is x, this one is y. Okay. Now these are two different elements. So first of all we have to represent it by two circles. Now x is less than y, so we should place x below y. Okay. हा जर y असेल हा x असेल तर x हा y च्या खाली असला पाहिजे because x is less than y. So in this way we can place those elements. Now we have to draw a direct line between x and y when if x is less than y and if y covers x and if there is no any element between x and y, then only we can connect x and y directly by single line. Okay. So here we will consider one example. From that you will get idea about what is a Hasse diagram. Okay. So consider set x is given which is consist of all these elements. Then relation is a partially ordered relation such that x is less than equals to y if x divides y, or we can say that x is partially ordered relation with y if x divides y. So this is a given condition, that is x divides y. So draw the Hasse diagram for x partially ordered relation. Now we have to represent this relation by a diagram, and that diagram is a Hasse diagram. So one condition is given that x divides y. So consider first element, that element is 2. So it should be represented by a circle. Then next element is 3. Now there is no any relation between 2 and 3 because 2 can't divide 3. That's why we have to consider this element 3 as a separate element, and again that should be represented by another circle. Okay. Now consider next element, and that element is 6. Now both 2 and 3 are dividing this element 6. So that should be connected by a single line. So 2 divides 6, 3 divides 6. Now next element is 12. So now consider this 6 divides 12. That's why I have placed here direct line from 6 to 12. But it is not possible to draw a direct line from 2 to 12 because here there is one line from 2 to 6. 2 directly divides 6 and 6 divides 12. So it is not required to give line from 2 to 12 because it has been covered from 2 to 6 and 6 to 12. Now next element is 24. Now 12 divides 24 and next one is 36. 12 also divides 36. So there is a line from 12 to 36. Now if you observe, if you check the line from 2 to 12, so it is covering elements 2, 6, 12 and 24. So for this 24, all these are elements, those divides 24, that is 2, 6, 12, 24. Now if you observe 36, so we can say that all these elements like 2, 3, 6, 12 and 36, all these elements divide say 36. So all these conditions, that is x divides y, this condition is satisfied by this Hasse diagram. That's why this is a correct diagram for given relation.
हॅलो मॅम.
So hello,
मॅम खूप फास्ट व्हायला लागले.
फास्ट व्हायला लागले.
Yes, ma'am. Ma'am.
हा मॅडम काही समजा गेले, खूप फास्ट झाले.
Hasse diagram
हो,
नाही
ma'am.
समजले का?
मॅडम वरचं पण नाही समजलेलं.
काय समजलं नाही. ऍक्च्युली जोपर्यंत तुम्हाला हास्य डायग्राम कळत नाही ना, तोपर्यंत आधीचे हे जे डेफिनेशन्स आहेत ते समजणार नाही, म्हणून आधी मी हास्य डायग्राम्स घेतले.
मॅडम खूप फास्ट व्हायला लागले लेक्चर मध्ये.
बरं सांगा, काय समजलं नाही, तिथून सुरुवात करू. इथेपर्यंत तरी समजलं का पार्शियल ऑर्डर्ड रिलेशन कुठले कुठले आहेत? हे रिलेशन आधी आपण डिफाईन केलेत. लेस दॅन इक्वल्स टू असेल तर ऑर्डर पेअर काय येतील, ग्रेटर दॅन इक्वल्स टू असेल तर ऑर्डर पेअर काय असणार आहेत. बरं तुम्ही सांगा कुठून समजलं नाही, परत स्टार्ट करू.
मॅडम ही पार्शियली ऑर्डर्ड, टोटली ऑर्डर्ड काही समजलं नाही.
इथून का? ओके
हा फास्ट झाले.
ओके. पार्शियली ऑर्डर्ड रिलेशन म्हणजे काय आहे? जर ते रिलेशन 3 प्रॉपर्टीज सॅटिस्फाय करत असेल तर. अँड व्हॉट आर दोज 3 प्रॉपर्टीज? रिफ्लेक्सिव्ह, अँटीसिमेट्रिक अँड ट्रान्झिटिव्ह. जस्ट डेफिनेशन इज गिवन फॉर पार्शियली ऑर्डर्ड रिलेशन. डेफिनेशन समजली का? Just we have to check for 3 properties: reflexive, antisymmetric and transitive. ह्या जर तिन्ही properties त्या relation ने satisfy केले, then only we can say that that relation is a partially ordered relation, or that set is poset, that is partially ordered set. ही definition समजली का?
येस मॅम.
Okay. Now we have to see what is a toe set. आता आपण काय बघितले, जर एक सेट आहे जो पार्शियली ऑर्डर्ड आहे आणि जर त्यापैकी सगळे इलेमेंट एका लाईन मध्ये असतील तर त्या सेटला आपण काय म्हणणार आहे? टो सेट, दॅट इज टोटली ऑर्डर्ड सेट. टो सेट म्हणजे काय? चेन. आता चेन मध्ये कसं असतं? All the elements are placed in a sequence. One by one elements will be placed. So it forms a chain. So this is called as toe set. हे जर example consider केलं, so this is called as toe set or chain because all elements are connected in single chain. तसं जर हे example तुम्ही second consider केलं तर ह्याला आपण टो सेट म्हणू शकतो का? नो, दिस इज नॉट ए टो सेट बिकॉज दिस इज नॉट फॉर्मिंग ए चेन ऑफ इलेमेंट. चेन म्हणजे काय? फक्त एक साखळी असायला पाहिजे, देन ओनली वी कॅन से दॅट टो सेट. नाउ यू हॅव टू टेल मी वेदर दिस वन इज अ टो सेट. Hello? Whether this one is toe set?
येस मॅम.
Yes, because this is a chain of elements. मग तेच सांगितले, वेगळं काहीच नाही आहे. आणि जर एखादं पार्शियली ऑर्डर्ड रिलेशन रिप्रेझेंट करायचं असेल डायग्रामॅटिकली तर त्या डायग्रामला हॅसे डायग्राम म्हणायचे, जी की आता आपण बघितली. हॅसे डायग्राम कशी ड्रॉ करायची ते. जर हे सगळे एलिमेंट असतील तुमच्या सेटमधले आणि रिलेशन काय सांगितलंय? एक्स डिवाइड्स वाय. Now we have to draw that diagram such that every pair must satisfy x divides y. त्यासाठी आपण हे एक्झाम्पल घेतलंय. 2 3 घेतलं. So can we place direct line between these two elements 2 and 3? No, because 2 cannot divide 3. That's why we have to place these elements 2 and 3 at two different places. Okay. Now both 2 and 3 are elements, or we can say these are elements those divide 6. That's why 2 3 and then direct line to the 6. Now next one is 12. So here 6 divides 12. आता जर 6 पासून 12 कडे लाईन असेल, so it is not requires to give line from 2 to 12. 2 पण डिवाइड करतस ना 12 ला, but there is line from 2 to 6 and 6 to 12. So it is not requires to give direct line from 2 to 12. Okay. Again next one is 12 and that divides 24 and 36. So here if you check for any pair, that is 12 24 12 36, then 2 6 3 6 6 12, all these are satisfying the given condition x divides y. So here we can say that we have represented this given relation using Hasse diagram. अजून एक एक्झाम्पल घेऊया. So here in this example they have given one set P, and which is consist of elements phi, set A comma B and set A comma B comma C. Okay, and which relation is given? Inclusion. So this is the relation we have to define on this set P. Hasse diagram काय येईल हे विचारले. ओके, आता inclusion म्हणजे काय? Again this is the concept of subset. Now first element is phi, so that can be represented here by using circle. So phi is represented by using this circle. Next element is set A. So now phi is subset of every set. That's why phi is a element of this set A. So we can connect these two sets by direct line. Okay, that's why we have placed this line. Now next one is set A comma B. Now set A is subset of set A comma B. That's why we have connected these two sets by direct line. And next one, set A B C. So again here set A comma B is a subset of set A B C. That's why we have connected these two sets by direct line. So again all the elements of this set forms a chain. That's why this one is called as toe set, that is totally ordered set. Understood now? Hello?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So in the next lecture also we are going to solve more examples based on A. So again you will get clear idea about it. I think time, so still 15 minutes are remaining. Let us consider next example. Let A be a given finite set and P of A its power set. Let subset be the inclusion relation on elements of P of A. Then draw the Hasse diagrams of partial ordered set P of A subset for A is equals to set A. Okay. So now we will see what is meaning of this. Just they have told us that we have to draw a Hasse diagram for a set, and that set is P of A, means what? Partially ordered set, and that should satisfy subset relation. Okay, so first set is given as set A. So first of all you have to find what is the power set for this set A. Power set काय येणार आहे?
5 comma A.
Is 5 comma A. Now we have to draw Hasse diagram for this power set. Okay, so how we can draw? So phi is represented by this circle, A is represented here by this circle. Now phi is a element of set A because phi is a subset of every set. That's why this is satisfying this given condition of subset. So this phi and set A are directly connected here. Okay. So likewise, if you consider set A, which is consist of two elements A, B, then first of all we have to find what is the power set of this set A. So power set मध्ये कुठले element असणार आहेत? If your set A is consist of two elements A and B, then its power set will consist of four elements. So what are those elements?
Phi comma A comma B comma A.
Yes. Phi, set A, set B and set A comma B. Okay. So now four elements are there and we have to represent it by Hasse diagram. So your Hasse diagram will contain four circles, each one to represent one element. So first circle is for phi. Now phi is subset of set A and set B. That's why there is direct line between set A and phi and second one set B and phi. So these two are connected by direct line. Okay. Now set A, set B, up to this we have drawn. Now next element is set A comma B. So here set A is a subset of set A comma B and set B is a subset of set A comma B. So again these two are connected by direct line. So this is the Hasse diagram for second set. इथेपर्यंत कळालंय का Hasse diagram कशी ड्रॉ केली?
Yes, ma'am.
Okay. Now consider third one, set A, which is consist of three elements A, B, C. So first of all tell me how many elements would be there in power set of A? Power set
Eight.
मध्ये किती element? 8. So what are those elements?
Set A comma phi, set A, set B, set C, set AB, set BC and ABC.
ABC, correct. Okay, and one more is set AC. Okay. So there will be total 8 elements. So first element is phi. So that is represented here by this circle. Now we have seen that phi is subset of every set. That's why for this set A, B, C, we have drawn direct line to phi because phi is a subset of all these three sets. Okay. Now next element is set A comma B. So we can say that set A, set B, these are subsets of this set A comma B. That's why there is direct line between these two sets. Okay. Set A and set B कडून आपण direct line का draw केली for this set A comma B? Because for set A comma B, set A and set B, these are the subsets. Okay. So likewise for this set B comma C, set B and set C, these are the subsets. So we can draw direct line to set B comma C from set B and set C. So likewise for set A comma C, set A and set C, these are the subsets. So we have placed here direct line. Now for set A comma B comma C, set A comma B, set A comma C and set B comma C, all these three are subsets. That's why for set ABC we have drawn here direct lines from AB, AC and BC. So this is the Hasse diagram for set A if your A is containing 3 elements. लास्ट डायग्राम समजली का कशी ड्रॉ केली आहे? हॅलो Do you have any question?
No, ma'am.
So take one question for homework. You have to draw Hasse diagram for this last set A, and which is consist of 4 elements A, B, C, D. So again tomorrow we are having lecture. So first of all I will check how you have drawn the Hasse diagram for this set D. Then we will proceed.
Hello, ma'am.
हॅलो
कालच्या नोट्स
Yes.
सेंड केलेल्या नाहीत
हां हां आज सेंड करते.
कॉनवर्कच्या
ग्रुपवर टाकली ना.
कॉनवर्कच्या काल शिकवलेल्या.
ओके ठीक आहे सेंड करते.
ओके मॅम.
Okay, so today we will stop here. Next lecture we will see. First we will revise what part we have covered today, and we will solve some more examples based on Hasse diagram. Okay. Present. Roll number 1.
Yes, ma'am.
2. Roll number 2. 3.
Yes, ma'am.
4.
Yes, ma'am.
5. 6.
Present, ma'am.
7.
Present, ma'am. Present, ma'am.
9.
Present, ma'am.
10. 11.
Present, ma'am.
12.
Present, ma'am.
13.
Present, ma'am.
14.
Yes, ma'am.
15. 16.
Present, ma'am.
17.
Present, ma'am.
18. 19.
Present, ma'am.
20. 21.
Yes, ma'am.
22.
Present, ma'am.
23.
Present, ma'am.
24.
Present, ma'am.
25.
Yes, ma'am.
26.
Yes, ma'am.
27.
Present, ma'am.
28. 29.
Yes, ma'am.
30, 31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35, 36, 37,
Present.
38,
Present, ma'am.
39,
Present, ma'am.
40,
Present, ma'am.
41, 42, 43, 44, 45,
Yes, ma'am.
46, 47, 48, 49,
Yes, ma'am.
50,
Yes, ma'am.
51,
Yes, ma'am.
52,
Yes, ma'am.
53,
Yes, ma'am.
54,
Yes, ma'am.
55,
Yes, ma'am.
56, 57,
Yes, ma'am.
58,
Yes, ma'am.
59, 60,
Yes, ma'am.
61,
Present, ma'am.
62,
Present, ma'am.
63,
Present, ma'am.
64, 65, 66,
Present, ma'am.
67, 68, 69,
Present, ma'am.
70,
Present, ma'am.
check for absent numbers. Roll number 5, 10, 15, 18, 20, 28, 35, 36, 41, 42, 43, 44, 46, 47, 48, 64, 65, 67 and 68.
Ma'am, 48 present.
48.
Ma'am, 35 present.
Ma'am, repeat again.
Roll number 2, 5, 10, 15, 18, 20, 28, 36, 41, 42, 43, 44, 46, 47, 64, 65, 67 and 68. Okay, so today we will stop here.
हॅलो मॅम
Lecture. Hello.
मॅम
Yes.
67 प्रेझेंट होता ते बॅटरी गेल्यामध्ये हे झाले ऑफलाईन गेला
Hmm.
त्यामुळं फिरसे जॉईन होणार नाही तो प्रेझेंट होता ते
Okay.
67